Lesson 20. Use simulations for compound events. Alrighty, our first question here says that we want to use a coin to simulate the probability of a parents having one boy and one girl. If they have a total of 2 children, a heads represents having a girl and a tails represents having a boy. The coin is flipped twice for each trial. The first coin represents the second child. The first coin represents the first child, and then the second coin represents the second child. The experiment was performed 12 times. The results are recorded in the following table. We want to know what is the probability that the parents will have one boy and one girl if they have a total of 2 children. Okay, well, first let's figure out our total, right? So how many total times did they flip their coin? It says here they performed it 12 times. So I know I'm going to have 12 in my denominator because that is the total number of times I did my experiment. Now they want to have one boy and one girl, which means I'm looking for every single time that I got one head and one tails. So I'm just going to go through my table and start looking for where I have one head and one tails, and I'm just going to circle them. All right, let's see. So when I count that, I would have 1, 2, 3, 4, 5 different options, or 5 different times where they flipped one head and one tails. So based off this table, they would have a 5 out of 12 chance of having one boy and one girl. There are 3 candidates for student council secretary: Greg, Brittany, and Eliza. There are also 3 candidates for treasurer: Trey, Fabian, and Paulina. The experiment consists of using 2 dice and is conducted to simulate the probability of Greg or Fabian being elected. The first die represents the secretary election. The numbers 1 and 2 represent Greg winning, and 3 and 4 represent Brittany winning, and 5 and 6 represent Eliza winning. On the second roll, that represents the treasurer election. Numbers 1 and 2 represent Trey, 3 and 4 represent Fabian, and 5 and 6 represent Paulina. Alright, so that's a lot of different information they just gave us there. But the question wants to know what's the probability that Greg or Fabian will win the election. Okay, well, let's see. So up here it says that if you roll a 1 or 2, Greg will win. And for Fabian, if you roll a 3 or 4 on the second one, Fabian will win. Okay, so our goal here is to look at, well, let's look at the first roll, and I'm going to pay attention only to the number 1 and 2 because that's what represents Greg, right? And then I'm going to look at the numbers 3 and 4 because that represents Fabian on the second roll. So on the very first roll here, the first die, I have 1, 2, 3 times where Greg could win. And on the second roll, there's only 2 options for Fabian winning. Now, this happened 8 times, right? Their trial, they did 8 different trials, and 1, 2, 3, 4, 5 of those options have either Greg winning or Fabian winning. Now, they don't both have to win at the same time because, again, this problem uses the word or, so we're looking for when either one of them will be winning. Our next problem says that a company is accepting job applications for a customer service position, and in general, around 75% of the applicants are qualified for the job. We want to know which simulation best models this situation. So what we're looking for here is we're looking for one of these options that give us a 75% chance of that event happening. Okay, so the first option says rolling numbers 1 through 4 represent qualified applicants and 5 through 6 represent unqualified. Okay, so that would be a 4 out of 6 chance or 2 out of 3. That is not 75%, so we're not going to pick A. The letter B says drawing a deck of cards where hearts, diamonds, and clubs represents a qualified applicant and spades represents unqualified. There's 4 total suits and cards, and 3 out of those cards represents a qualified applicant. So 3 over 4 is the same as 75%. So B would be the choice I want to pick here. The next one says that Erica plays for a volleyball team, and in general, 10 out of 12 of her serves are successful. Okay, so we're looking for a probability that has 10 out of 12 being successful, or if I simplify this, it would be 5 out of 6. Okay, so sometimes the simplified version might be helpful. Number A says that rolling a die where numbers 1 through 3 represent successful serves and 4 through 6 represent unsuccessful serves. Well, that would mean she would have a 1/2 chance, right? Because 1 through 3 versus 4 through 6, that's a 50-50. So A doesn't work. B says rolling a die where numbers 1 through 5 represent successful serves and 6 represents unsuccessful serves. Well, when you roll a die, there's 6 total options, right? And 5 of those represent successful serves. 5 over 6 is the same as this probability up here, so B would be the answer choice I want to pick. Okay, again, so read through the scenarios carefully, and you're trying to find one that gives you the probability that matches the question you are given. Here says, in 2 different neighborhoods, 50% of homes have at least one pet. We want to know which simulations can be used to determine the probability of choosing 2 homes at random, one from each neighborhood that are homes with a pet. Okay, so we want to, again, pick an option where 50% of those homes have at least one pet. This first option says that flipping a coin twice, let heads represent a home with a pet, and let tails represent a home with no pets. Third option says flipping a coin, let heads represent a home with a pet, and let tails represent a home with no pets. Oops, those are the same. So since they're the same, technically both of them give you a 50% chance, but I'm just going to select one of those. I'm double checking here. Okay. Let's move on to C and D. C says that draw 2 cards, let a red card represent a home with a pet, and let a black card represent a home with no pets. If you think about a deck of cards, half of them are red and half of them are black, right? So this also gives us a 50-50 chance of that happening. This one down here says let a face card represent a home with a pet and a numbered card represent a home with no pets. That does not count because that's not 50-50, right? There's many more numbered cards than there are face cards. Also, I see what the difference in these 2 problems now is. This first one says flip a coin twice, and this bottom one says flip a coin once. You want to flip a coin twice. Okay, so if we're flipping a coin twice, that would be the same thing as having 2 different neighborhoods. So that's why that's important. Okay, so flipping a coin twice. Next question says, suppose a school has 2 movie clubs, one for 7th grade and one for 8th grade. In each club, 4 people prefer to watch science fiction movies and 2 people prefer to watch comedies. Which simulation could be used to determine the probability of randomly selecting 2 people, one person from each club that like the same type of movie? Okay, so we want to, let's see, there's 2 different clubs, one for 7th grade and one for 8th grade. In each club, 4 people prefer to watch science fiction and 2 people prefer to watch comedies. Okay, so we want to pick a option where if I select 2 people at random, one person from each club would like the same type of movie. Okay. Now, if I were to roll a dice 2 times, we don't want that because if I'm selecting only one person from each club, sorry, let me backtrack. I read that wrong. I'm selecting 2 people, right? Which means I need to roll a dice 2 times, once for each person. So both of these that say roll your dice once, we're not going to pick those, okay? Because we need to roll it twice, one for each person. Now, it looks like 4 people prefer to watch science fiction and 2 people prefer to watch comedies. So I need to have a 2 to 4 ratio. Okay, so whatever I choose, I need to have more people that prefer to watch science fiction and less people that prefer to watch comedies with whatever method I'm using. So if I were to let multiples of 3, which would only be 3 or 6 on a dice, represent a person who likes comedies, that is 2 for comedies, and let all the other numbers, which would be 4, represent science fiction, that would work. This one down here, where I'm letting even numbers represent people who like comedies and odd numbers represent people who like science fiction, this does not work because that is a 50-50 chance. But from our problem, it's not the same amount of people who like both in each of the sections, which is why this one works, because they're a little bit off skewed, but they also match the description. All right, I know those type of problems can be a little bit tricky, and you have to just make sure that you're reading them extra carefully. But if you would like any extra help or have questions on anything, please let me know. Other than that, have a wonderful rest of your day.